G'day, welcome. Going to be going through some more picoCTFs. Keen to get started, so I'll just jump straight into it. Today we're going to be hopefully maybe try and do 2 to 3 in the next hour and a bit. There's heaps actually. Let's just see quickly. Wow, there's so many easy ones. Then it gets to medium. Anyway, we'll work our way through it. How many are there in total? Wow, 43. Some hard ones. That's all good. We'll go through them. So there's 43. And there's 3, 6, 9, 12. Wow. Anyway, we'll try and do a few as many as we can. Description: can you conjure the right bytes? The program's source code can be downloaded here. Okay. Let's launch this. I think this is still loading. Oh, I have to download it. Okay, sure. See if the web shell's working. Wasn't working last time. Okay, it is working. Okay. Wow. Okay, this is interesting. Let's see the let's see. Okay, interesting. Okay, so looking at this challenge and what it's asking us to do, it says send me ASCII decimal 101 1751 times side by side, no space. Well, while doing my research, I know that that decimal is the letter E, and if you think about it, it'd be impractical to send that 1751 times side by side, no space. So what we're going to have to do is we're going to have to use a Python one-liner to generate the string and pipe it directly into the netcat command. Just for clarification, netcat is a versatile networking utility used for reading from and writing to network connections using the TCP or UDP protocols. It is frequently called the Swiss Army knife of networking because it can handle almost any task involving basic data transfer or connection testing. Okay. You can use it to interact with remote servers such as the Foggy Cliff Pico CTF.net server used in your challenge. Port scanning, it can check if specific ports on a target machine are open or closed. Banner grabbing, it can be used to identify the version of a service running on a port. File transfer, you can pipe files through netcat to move them between two machines on a network. Simple backdoors. In cybersecurity testing, it is often used to create reverse shells, allowing a remote user to execute commands on a system. So pretty much the host. So in the Byteman C1 challenge, the NC command, NC standing for netcat, is used to establish a raw connection to a specific host and port. The host is foggycliff.picoCTF.net and the port is 50424. Okay. So Python, so just a breakdown of the command. Python 3 calls the Python interpreter. -C is the command line flag that tells Python to execute the code provided as a string directly in the terminal rather than looking for a py file. Okay. Print, standard Python function that outputs data to the terminal. E, this represents the lowercase letter e in the challenge the server asked for. ASCII decimal 101. In the table, the decimal value 101 corresponds to the character E times 1751. In Python, when you multiply a string by a number, it performs string repetition. It creates a single string consisting of the character E repeated 1751 times. There we go, we got the flag. Okay, the reason we had to do the command from the main is because by running them together from the main prompt, Python pulls all those characters into the tunnel and Netcat catches them and throws them at the server the millisecond the connection opens. Why it failed inside the connection was when we typed the command while already connected, the remote server treated the command as literal text. Okay, let's go. Printer shares challenge. Actually, before we do that, I'll just create some notes for the Google Keep. To solve challenges requiring massive or precise input, use the Linux pipe to connect two programs. Example. Yep. So the first part prints E 17,051 times, and the second one connects to this to what we need to connect to. The pipe pours the output of the first command into the second. Okay. Python one-liners. The C flag allows executing code directly in the terminal. Character times n generates a string of length n instantly. ASCII mapping. Character E is equivalent to decimal 101 or hex x65. Netcat, known as the Swiss Army knife of networking, used to establish raw TCP/UDP connections to remote hosts and ports, essential for interacting with CTF service instances. Commands with pipes must be run from the main shell prompt. Running them inside an active netcat session sends the command as literal text rather than executing it. Perfect. Okay, that's done. Let's go to printer shares. Okay. Oops, someone accidentally sent an important file to a network printer. Can you retrieve it from the print server? Additional details will be available after launching your challenge instance. So the printer is on. Okay, so after NC dash, the V stands for verbose, which tells Netcat to give you more details about what it's doing. And Z is zero IO mode, tells Netcat to only scan for an open port without sending any data. Okay, that's cool. So usually a printer speaks by sending data to whoever connects. So you just need to establish a real connection without the Z flag and see what the server sends back to you. It's taking a while. Must be a massive file. Maybe I should refresh and try something else. Because the file is so big, what we'll do is that we'll redirect it into a text file once it's done. And then we'll manually try and look through and see if we can find the flag. Yeah, I'm having some trouble. Not sure how to figure this one out. So anyway, we'll keep grinding, try and get it done. Okay, so after some research, I started to look at the hints because I could not figure out how to get this going. But SMB, which stands for Server Message Block. So it says knowing how Server Message Block protocol works would be helpful. Then SMB client and SMB util are good tools. Okay. So as suggested by, well, first of all, the hint points specifically to the SMB protocol. We know that Netcat isn't the best tool for the job now. SMB is a protocol used by Windows and Linux for sharing files and printers over a network. While Netcat is great for raw connections, it doesn't speak the complex language of SMB. This explains why our previous connection resulted in a 0-byte file. The server was waiting for a proper SMB handshake, not just a raw text. Okay, using SMB client. As suggested by hint 2, SMB client is the standard tool for interacting with SMB shares from a terminal. To list the available shares on the server, see where the files are hidden, we can use this command. Hmm. Okay. Okay. Nice. Okay. That was a bit tricky, so I had to use a bit of knowledge of SMBs and printers and sharing to figure that one out, but that was a good. That was a good challenge, actually. Um. Okay. Let's quickly input the flag before it gets timed out. Nice. Okay, so I just want to run through the different files. So the different commands. The first one, SMB client, is the primary tool used to talk to servers using the SMB protocol, common for Windows and Linux file shares. Dash, capital L, stands for list. It tells the tool to ask the server, what folders or printers are you currently sharing? Mysterious-c.picoCTF.net, the host, which is the remote computer we are talking to. Dash P 5825 is the specifies the port, while SMB usually lives on port 445. CTFs often move services to high random ports to keep them isolated. And dash N stands for no password, anonymous. It attempts to list the shares without asking you for a login, which worked in your case to reveal the shares folder. Okay, so that was the discovery phase. Then this second line, so we got the different shares names. So we got shares, we found IPCS, and then we asked to, okay. Then we go to the access phase. So SMB client, like we talked about before, and then we did -- mysterious c picoCTF.net/shares. This is the UNC, Universal Naming Convention path. The host name tells the computer which server to visit, and the shares tells the server exactly which room share name you want to enter. Okay, that's cool. Interactive mode, because you didn't use L flag this time. SMB client usually opens a connection and gives you a new prompt. Okay. Once you are at the prompt, you aren't just looking at the server anymore, you're inside it, ready to use commands like list and see files and get to download them to your own machine. So that's what we did. So we found shares. Okay, so the first line that we did was the discovery. Second line was the access. Once we were inside, we list what the contents were, and then obviously flag.txt. We did get to download that onto our own computer. We exited, and then we used cat to reveal the contents of inside that text file. Perfect. I think we have time for one more flag, but first let's get the notes. Before we continue, let's just look at what SMB is. So SMB, server message block, is a network communication protocol used for sharing access to files, printers, serial ports, and other resources on a network. It operates primarily as a request response protocol, where a client asks for a specific resource and the server responds by providing it. Okay. Key characteristics: file and print sharing. It is the foundation of network drives in Windows and file sharing in Mac operating system and Linux via Samba. Client server model. Client like SMB client tool connects to a server to access shared data. Evolution has evolved through several versions to improve security performance. Port usage: while modern SMB typically use port 445, CTFs will change that. In cybersecurity, SMB is a common target for enumeration, the process of gathering information about a target. Anonymous access. Many challenges and some misconfigured real-world servers allow guest or null session access. This is why the end flag in your command worked. It bypassed the need for a password. This share servers divide their resources into shares. Some are administrative, like $$ or IPC $, while others are created by users, like the shares for the found information leakage. Even if you cannot access a specific file, listed the shares using SMB client L can reveal usernames, software versions, or the purpose of the server. Or the purpose of the server. Give me one sec. Okay, so we've got the notes for SMB Printer Shares Challenge summary. So the first thing is the core concept, SMB protocol. Server message block is used for sharing files and printers on a network. Why Netcat failed? Well, it failed because Netcat sends raw bytes, but SMB requires a complex handshake protocol that NC doesn't speak. The nudge, some servers are passive and won't send data until you send a specific request or a new line enter. Discovery, enumeration, port scanning, use NC-VC host port to check if the service is alive. So that's what we did at the start of that challenge. Then we listing shares, we used SMB client-L with the host and then P for port and then end, which would mean no password to see available folders and printers, which is here as well at the bottom. And then access and retrieval, SMB client, host, share name, port, and internal commands. So that's how we get into the actual connect to the actual server. And then internal commands, so you have list files in the share, get file name, download the file to our local machine, and then reading the flag once downloaded and exited, you can use cat file name, which is exactly what we did. Cool. We got about 20 minutes, so let's try and smash through one more challenge. Ping CMD. Okay, that sounds fun. Let's try this one. Can you make the server reveal its secrets? It seems to be able to ping Google DNS, but what happens if you get a little creative with your input? These are available once you launch your challenge instance. Okay. Let's connect to the service. Okay. Enter an IP to ping, but we have tight security only allowed this. Okay. Interesting. What's a challenge? Okay. Okay, the ping CMD challenge is a classic example of command injection. The server is taking your input and placing it directly into a system command, likely ping C to input. The trick is to use command separators to finish their ping command and start your own. Okay, vulnerability, command injection. In Linux, you can chain multiple commands together using specific characters. Semicolon runs the second command after the first one finishes, and symbol runs the second command only if the first one succeeds, and pipe passes the output of the first command as input to the second. Since the server says it has tight security and only allows 888, let's see if we can bypass that check by including 888 followed by a separator. Oh, what is that? Okay. So now we're going to try. Now we're going to try the same thing, but with the separator and the list command. Let's try that. Interesting. So the server first executed the ping. Because of the separator, it then executed the list command. So then we found a flag.txt. So now what we need to do is should we do 8.8.8 followed by semicolon list. But now instead of list, let's do cat and flag.txt. Why this works, the server thinks it's just running a ping, but you've injected a second command that developers didn't intend for you to run. This is common flaw in web applications that pass user input directly into a system shell. There we go. We've got the flag. Perfect. I think we'll create some notes quickly. Cool. So yeah, we already went over these. This is just for memory sake, but I think that was a pretty straightforward sort of CTF, but it was still good because it's one of the most common vulnerabilities, but in a basic form. So going forward, when we start to do more complex ones, that'll be a good reference point. Okay, let's do, okay, byte min C0. Can you conjure the right bytes? The program's source code can be downloaded here. Send me ASCII decimal 101, 101, 101 side by side, no space. Okay, I guess that's a good one to finish off. I guess there you go. So the good thing about, if I'd have done this challenge first before the other one, I would have been confused. But I guess that's the good thing about doing CTFs, is that we'll learn, even if they're simpler, we can learn and you can recognize patterns in the future. Boom. That was a good one. Only 76% liked as well, so no wonder. Yeah, no, we'll call that for today. I don't need to create notes for this one. I think that should be, it's good. We completed 4. At this rate, it'll take us around 100 days to complete all of these, but maybe even more. That's assuming I don't take days off. But yeah, been streaming now for around an hour and a bit. Got some general skills, web exploitation, cryptography coming up, general skills. All of we've done is general skills so far. So I think going forward, yeah, I think I should be able to speed through these easy ones quicker as time goes on. Once I start to pick up on patterns and techniques that I've done before in the past, I'll know straight away, all right, I need to do this, I need to do that. Got blockchain, binary exploitation, general skills, forensics, reverse engineering, cryptography, web exploitations. Pretty cool. Alrighty, thank you very much. I'll see you next time.